Hi guys, this graph or this diagram looks so complicated, but it's the whole statistics mixture. So it's very easy. So I'm gonna so hopefully you can pass in your exams. So statistics. For this is a study. So we have a research questions. For example, if we can take is aspirin is good for heart patients or not, and then we going to do some research on it. And for this, first of all, we have a for example, we have a research questions, and we have to find out. So our study design. So we have to confirm our study design. So there are two types of study designs. One is observational and one is experimental. So observational and experimental, so we have to choose one design studies design, and it so depends what kind of study we are going to do it. For example, we are going to do observational study is you are going to observe your patients. You're going to give a medicine, and then you're going to observe how the outcome, how the medicine will work on it. So we have two type of groups in it is retrospective studies and prospective studies. And experimental design, we have to for example, depends what kind of the design has. The patients are randomly selected or the patients are non-randomly selected. For example, we are going to observe the patients for lung cancer. Smoking causes lung cancer, and one we have an experimental group and one is we have a control group. One the peoples who have a lung cancer but they never smoke. So these kind of studies we can randomly and non-random randomized, we can choose that, right. This is a short review for it, and then if we can go to what kind of data is it. Our data is a quantitative or qualitative. So what is the difference between qualitative and quantitative? Qualitative data is like there is no numbers in it. For example, we can divide into ordinal, nominal and binary. So ordinal, we can give them a order. Order is like, for example, the grade of cancer, and we have for example type, the patient has stage 1, stage 2, stage 3, stage 4, so we can order them. And nominal category is we don't need to order them. For example, if we can say grades of hematology, so we don't need to grade them, isn't it? And binary, what is binary? So binary is like outcome. For example, man, woman, male, woman, male, woman, girl, boy, sky, earth, dead, alive, and this type of data is called binary data, right? So, and the other data is like quantitative data. This is quantitative data. So there is a like a numbering. There's a number in it, right? So that's a quantitative, counted. So this data is discrete and continuous. So what is mean continuous and what is mean discrete? Like if the there is like, for example, oh, the aged the old age is very miserable age. So this here they mention the age but not the number. So this is it's like discrete. So continuous, they mention the age, they mention the height. The man, this man is 24 years old, this man is 25 years old. So we mention the age, we can mention the BMI, we can mention that this my height is 5 foot 6 inch. I mention my height, so we can mention the numbering in it. So it is called continuous data. Okay. Or for example, first we need to sort it out. Quantitative, what is quantitative? All these things, if for example if my data is ordinal or nominal, any of them, say, and I have to do my hypothesis testing. And hypothesis testing, first of all, we have to find out two important things. One is important thing is we need to find out the confidence interval, and we have to find out the relative risk, absolute risk reductions, relative risk reductions, and outright share. So I don't have a time to explain all these, but this is, you know, very well. And also, if we are going to find this, and then to find, after we find out the how much the relative risk, and then we have to put our data in this test. There are four kind of different tests used: chi-squared, Fisher exact, and z test. We use these ones, any of these ones, and then and there is, okay, we plotted our data on the graph, and there is not a, something is not normal. And for example, if we get doing correlations and regressions, and then our data is not normal on it, so we have to adjust our data by, what is correlation? Correlation is mean association between two outcomes. So so we have to do logistic regression, or we have to use yeast correlation to adjust our data. So this is for only qualitative data. Okay, right. How to do the quantitative data? We can't use these all things for our quantitative data, so we have to use so what we need to do, okay, now our, for example, our data is like continuous data. Leave this one, continuous data. So this is we have to find out in our data now mean, median, and mode, right? So what is mode, what is medium, what is mean is how to find out mean. So we have to if we have, for example, I have 1 2 3 4 5 6 7 8 9 10 numbers, yeah. Then 10 numbers I have to calculate it and then divide it by 3, so we can get the mean. And medium, medium is the middle number. We have some values, and then we have to order them, and then we have to middle value from them. And mode is the most occurring value in this sequence. So we have to find out, but we are going to find only mean here, because we need to find out the p-value. So we need to find out the p-value, so we have to understand that we have to find out two things. We must know the mean and standard deviations. So mean is we can calculate it, and for example, we have a mean, and then we can use our mean to find out the p-value. So how the p-value, say for example p mean, and then we will use this to find confidence with a formula for it. We know the formula, and then we find the confidence intervals, and when we need, and find out the p-value, and then we use it hypothesis testing. I'm going to explain in a minute. And then we also use our mean values to calculate standard error, right? And standard deviations, we can calculate the standard deviation. We need to find out the p-value by standard deviation. So standard deviation, we for standard deviation, we need to find out, first of all, we need to find out we have to find out the standard error. And then after standard error, we will, this is what I'm telling you about the standard deviation. So for standard deviation, I want to get a p-value from standard deviation. So standard deviations, I have to find out standard error. When I will find out the standard error, and then easily I can get confidence interval. If I get a confidence interval, I can calculate the p-value, and then I can easily tell the hypothesis testing, right? And also mean and standard value can tell us the how much normal our data is. So for example, we plot we have a data, and we plot on a graph on it. So mostly, like, we can use histogram, can tell us the tell us is the data is normally distributed or not, right? So we plotted histogram. If the histogram is shows normal distribution, so we can say our data is normal. If our data is not normal, so it's a skew data, we have to fix it, right. And now we can go there. So p-value, so we find out the p-value here. So why we find out the p-value? Why? So because if the p-value is 0 point less than 0.05, so it means our hypothesis, what is hypothesis? For example, there are two type of hypothesis. If I say aspirin is good for heart patients, and this is my null hypothesis. No, it's alternative hypothesis, and null hypothesis is like my aspirin is not good for heart patients. So if p-value is 0 point less than 0.05, so it means our hypothesis is hypothesis is right. And so that's why we're going to calculate the hypothesis testing. And then also or either if we know our data is parametric or non-parametric. So parametric is if our parametric is our data is parametric, and if there are two groups in our research study, so we are going to do t-test. If more than two, we're going to do ANOVA. After ANOVA we want to confirm our test is okay or not, so we have to post band friendly test. We're going to perform it. And if our data is like non-parametric, is the assumptions not met. What does the assumptions? You can read in your notes because I have not much time. So if assumptions are not our data is not parametric, not associated with each other, so we are going to, if two groups, we are going to do the Mann-Whitney test. If more than two groups, we are going to do Kochel-Wallis-Friedman test, right? And then this bit left over I will upload in the other video. Thank you.